Using trig ratios to solve triangles. Angles. Trig ratios can be used not only to find the lengths of sides of a right triangle, but also to find the measure of the angles. The steps are the same as the ones we use to solve for a side, but the process will look a little different. First, you're going to choose which trig ratio to use, sine, cosine, or tangent. You're going to write the trig ratio and substitute the values. And then you're going to solve for the angle using the inverse ratios. When we want to denote inverse, we put what looks like an exponent of -1. That it means inverse. Right? And we know it's an inverse because it's on a function. If it's on a function that -1, it means inverse. It doesn't mean an exponent of -1. Sometimes we call those that sine with the -1, sometimes we call that arc sine. We also can call cos with the -1 arc cos, and tan with the -1 is arc tan. And we can write them out that way as well. So this is arc sine. This is arc cos. Oops, missing a C. And this is arc tan. Right? So those can be used interchangeably. And by the way, this is all in your notes as well. I think only part of this page is, and then I'm going to do an exploration, and the exploration's not in the notes, but you just need to pay attention. So trigonometric ratios, the ratio of the lengths of two sides of a right triangle is called the trigonometric ratio. The three most common ratios are sine, cosine, and tangent, which are abbreviated sin, cos, and tan respectively. Sine, so if we look down here at our picture, sine r is the leg opposite angle r, and so that would be side r, right? So side r is the side opposite angle r over the hypotenuse, right? And the hypotenuse is opposite the right angle. Cosine r is the leg adjacent to angle r, so the leg adjacent is the one next to is side s over the hypotenuse. The hypotenuse is t, it's opposite the right angle. And then tangent r is the leg opposite angle r, so that would be side r, over the leg adjacent to angle r, that would be side s. Right? And that's how we write our ratios. Once we have our ratio written, we can solve for any of the three. Any three can be an unknown. The angle can be an unknown. This is the angle. The side can be the unknown. That's in the numerator, or the other side can be an unknown. And depending on which trig rate function we use, we can solve for the opposite, we can solve for the hypotenuse, we can solve for the adjacent side, and we can solve for any angle. Right? Just using what we're given in terms of the sides of the triangle or the angle of the triangle. Alright, so example, evaluate the three primary trig functions. So this is just a little exploration. This is not in your notes, I don't believe. Alright, so, and then we're going to learn how to find the angle measures using the table and using the calculator once we've done a little exploration. Alright, so I'm going to find, we're going to find both angles, angle A and angle C. Alright, so let's start off with angle C. Got a little glitch there. All right, so let's find sine C. And so from angle C's perspective, this side is the opposite. It's opposite the triangle. This side is the adjacent. It's next to angle C. And of course, opposite the right angle is the hypotenuse. So sine C is opposite over hypotenuse. That's going to be 5/13. Cosine C is the adjacent side, which is 12 over the hypotenuse. That's 12/13. Boy, that's kind of bothering me a little bit. I am just going to write it down here and drag it up. Yeah, that looks much better, doesn't it? And then finally, let's find tangent. Tangent C is opposite over adjacent, so that's 5 over 12. And I should have done this over here so that I can just drag it in and it would be readable. Now I'm just going to take those sides, the ratios of those sides, and just convert that to a decimal. And we'll be using that in a little bit. All right, so let me grab a calculator. And that's it. There it is. All right, so we have 5 divided by 13. So that's, and I'm just going to list, I'm going to round to 4 decimal places. So that's 0.3846. And there goes our calculator. And let's get it back again. 12 divided by 13. Of course, it's going to keep going every time I go to write. 0.9231. That would round up. And let's get it one more time for 5 divided by 12. 4.167. Point 4. I accidentally said 4 instead of 0.4. 0.4167. Sorry. All right, let's do the same thing, but let us find let's find the ratios for angle A. We can use either acute angle. And here, since we have all the information, we can actually write all 3 trig ratios. We won't always be able to write all 3 trig ratios, but here we have all the sides. All right, so now let's change these to match what is opposite and adjacent to form angle A's perspective. Of course, the hypotenuse wouldn't change, but now this is the opposite side because that's across the triangle from angle A, and this is next to angle A, so this is the adjacent side. So sine A is going to be 12 over 13. Cosine A is going to be 5 over 13. And so notice that cosine and sine just switch, right? Because opposite and adjacent switch when we change which angle we're working with. And then tangent's just going to be the reciprocal, right? Because now 12 is the opposite and 5 is the adjacent. Well, if I want the decimal equivalents, for those ratios, right, 12 divided by 13 we know is 0.9231. And 5 divided by 13 is 0.3846. And actually, 12 divided by 5 is actually really a nice number because it would go in 2 times, and there would be 2 leftovers. So that would be 2 and 2/5. Well, 2/5 is the same as 0.4. So this one is a nice one. This one is just 2.4. All right, so now we can use that table that we use. Remember the table of trig values? We use those to find sides. We can go the other way and find angles. All right, so let's look from angle C's perspective first. All right, angle C had a sine ratio, and I'm just going to write the decimal, of 0.3846. And a cosine ratio, oh, actually, sorry, I forgot to put in the C. Got to take the sine of something and the cosine of something. And a tangent ratio of 0.4167. All right, so now let's look at the table, which is hiding. It's hiding right behind there, behind this too. Let's see if I move it down. There it is. All right, so let's see if we can kind of see both things. All right, so we're gonna look at the table, and we're gonna be looking for sine to be 0.3846, cosine to be 0.9231, and tangent to be 0.4167. Now, I have one little caveat here. You're not going to find the numbers necessarily exactly, right? Because we can find not only whole number angle degrees, but we can find a tenth of an angle, or a hundredth of an angle, or a thousandth of an angle. But our table is only written in whole angle increments. So we're going to find the value of sine that's closest to 0.3846, and the value of cosine that's closest to 0.9231, and the value of tangent that's closest to 0.4167. And it's okay if they're not exact. So let's look at our table. Let's look for the 3846 first of all. All right, so we're looking down sine, as I can see both now. All right, so I'm in the 0.3s. All right, so I got 0.3746 or 0.3907. Oh, it's pretty close. It's almost like halfway in between those two, isn't it? So let's see. It's from the 3746. It's actually missing a point there, but it's 0.1 away. I think it's just a little closer to this one, just a little bit. Whoops, I guess it doesn't let me write on that. I have in the past. Let's try it again. I've never had it where it wouldn't let me write. We wrote on them. Oh, that's just weird. Huh. Wright's over here. It shouldn't care. Nope. All right, so let's just write that down, that it was at 23. Maybe I should get the other table out. So let's put about 23 degrees. All right, and now let's look for 9231. All right, so notice that we're pretty close to 9205. Hey, that's at 23 degrees. What about tangent? Let's find 0.4167. Well, notice it's between 22 and 23. And I think it's just a tad closer to 23. If we weren't sure, we could put 22.5. So notice we got the same answer whether we used, and I didn't leave myself enough space for angle A. I'm going to get rid of this. We got the same answer whether we used sine, cosine, or tangent, because the ratios all describe the exact same angle. Right? So it doesn't matter which ratio we use. We're going to use whatever matches the sides we have. And no matter which ratio we use, right, we will get the same answer. All right, so now let's try the same thing. Let's try it with angle A. All right, so sine A was 0.9231, and cosine A was 0.3846, and tangent A is 2.4. And let's find how close we can get in the table without, I guess, apparently being able to write on my table. All right, so sine is 0.9231. So we got to look on the other side here. All right, so I see 9.9063, which I really wish I could underline. We got 0.9135, but I think we're a little closer, 0.9205. All right, let's see what was 0.9231. So notice we're in between 0.9231 is in between 0.9205 and 0.9272. And if I could write, I would, but right in there where you see blue flashes going. All right, so this angle is about 67 degrees. And let's see if we get the same thing if we look at cosine. And since we were kind of halfway in between those two, I can also put 67.5. And let's see about cosine. Or, cosine, yes, that's next. 0.3846. Well, notice if I look across, 0.3907. Cosine is going to fall in between those two as well, where there's like a little line, because that's all I can get. So again, we got about 67 or 67.5 degrees. All right, what if we look at 2.4? All right, so let's get the table on there for tangent. All right, so right in between 60, there we go, we got 2.4751 for 68 degrees, and we got 2.3559 for 66 degrees. So notice again the tangent ratio, so whether we are the sine ratio, the cosine ratio, and the tangent ratio are all closest to the angle that's 67 degrees. So what do you think? This is probably 67 degrees. Now we had to estimate, right, because we didn't find the exact number. We found what it was closest to. So we might find that it's 67.5 degrees, right? But it's going to be pretty close to 67 degrees. Now let's use the calculator, because the calculator it doesn't have to just work with whole number degrees. Oops. And as soon as we find my cursor, there we go. So let's get that calculator back. I can't believe I couldn't write on my table. That's crazy. So let's clear that. All right, so now when we plug this into the calculator, right, and I'm not going to estimate. So before I estimated that 0.3846, right, we rounded to four decimal places. I'm not going to round it all, right? I'm going to just use the whole value. All right, so I'm going to put in, and I'm just going to put in any one. Actually, I'll put in all three of them. All right, so let's first of all, I'm going to lose my calculator. I'll get it back though. Let's first of all find using angle C. All right, so we're going to have to take we're going the other way. So we're going to have to take what's called the arc sine of 5/13 to find out what angle C is. We could also find angle C using the arc cos, and that would be 12/13. Or we can find angle C using arc tan. And all arc sine and arc cos and arc tan do or go the other way. So sine, cosine, and tangent given an angle, with an angle give you a ratio, and then we can find the side measure. When we go the other way, arc sine, arc cos, and arc tan given a ratio tell you what angle that goes with. And that's all it is. So let's plug that in. So 5 divided by 13, and I am in degrees, 5 divided by 13 equals, all right, there's my ratio, right? We rounded to 4 decimal places. I'm not going to round it all now. And I need arc sine. And you see, I only see sine. If I hit that little shift button there, do you now see sine has a -1 on it? That's arc sine. And notice when I hit it, I get 22.6198. Let's round that to let's round it to 2 decimal places, I guess. We get 22.62. That's the degree measure of angle C. And notice we said it's about 23 or maybe 22.5, right? It was kind of in between 22 and 23. Well, you can see it really was in between 22 and 23 degrees. Exactly 22.62 degrees plus a few more decimal places. Oh, I just hit something there. let's do the same thing with the cosine ratio. So 12 divided by 13 equals, and now we'll do our cos. And notice we get the exact same answer, 22.619, so forth, which we'll round to 22.62. Let's see what happens if we use arctan. Right, and now we're going to hit arctan, and notice we get that same angle measure, 22.62. So we can use any of our trig ratios to find the measure of an angle. The only thing that matters is we have the sides for that particular trig ratio. So if we know the opposite and hypotenuse, we can use arc sine. If we know the adjacent and hypotenuse, we can use arc cos. And if we know the two legs of the triangle, then we can use arctan. Let's do the same thing, but this time with angle A. Yeah, angle A is the other one. So angle A, actually, let me write in a different color, just so it doesn't blend in so much. Angle A is equal to the arc sine of 12/13, right? It used the other side. It also equals the arc cos of 5/13. Or, let me move this down. The arctan of 12/5. All right, let's do the same thing. Plug these into the calculator. All right, so we have 12 divided by 13 equals, and now let's hit arc sine. So now we get 67.38 degrees. Notice we said it was 67 or 67.5 degrees using our table. So let's write that one down. So 67.38 degrees. And oops, I don't need the table anymore. We're done with your table. I just needed the calculator. We will use the table and the calculator for our problems, but I've already put a portion of the calculator on the lesson, so we won't have to keep bringing up that table, which is good because we can't even write on it. All right, let's do 5 divided by 13, our cos. Oops. Oh, well, it helps to hit equals. The calculator was letting me know that 13 wasn't okay. All right, so now we have our decimal. And notice we get 67.38 degrees again. Let's do the same thing with arctan. So 12 divided by 5, which is a nice pretty number, and we hit arctan, and we get 67.38 degrees again. All right, so the inverse ratios start with the ratio, and then you find the angle that produces this ratio. If we use the table, we can be accurate to the nearest degree. If we use the calculator, we can be more accurate. And you see, it doesn't matter which trig ratio you use. If you knew all three sides, you could just pick whichever one you wanted, right? But normally, often we'll only know maybe two sides. And so those two sides are going to dictate whether we use arc sine, arc cos, or arctan. Right? So the inverse ratio, start with the ratio and then find the angle that produces this ratio. They are sometimes also called the arc sine, arc cos, and arctan. On your calculator, these buttons will appear as follows. And even on the computer, right? We saw those buttons on my calculator. Right? So I think this is where I'm going to end, because after this we're going to be finding some angle measures and you're going to help me. Let me just check. Was this my last? Yes, it was. Whoops. And so that's the end of this video. Thanks for watching, and bye for now.